Okay, so in this video we're going to talk about the third method for solving systems of equations. The first one was graphing, second one was substitution. This one is called the elimination method because we are going to be eliminating variables. So let's look at the steps. Okay, so the first step that we're talking about is we're going to add or subtract the equations to eliminate one of the variables. Okay, so we're going to, our goal is to eliminate one of those variables. Typically, we eliminate by making sure that we're doing opposites. So we're taking add or subtract the equations to eliminate one variable. Okay, it may require what's called reordering. The terms, so making sure they're in the same order, or multiplication manipulation. So that means multiplying all of the terms by a factor so that you're able to eliminate some of those terms. Okay, so that's step one. Step two, once you've added or subtracted the equations, you solve the resulting equation You're going to solve the resulting equation for the other variable. Okay, so the goal is to solve that resulting equation. Okay, after that, step three is you're going to substitute your answer into either of the original equations. So you're substituting, let's put a little note in here. You're substituting the answer from step two into either of the original equations to find the value of the eliminated variable. Okay? Make sure always that you check your solution by substituting the ordered pair into both equations. Substituting the order pair into both equations. So we're going to look at a few examples just to make sure that we've got it. There's a couple of different things that you may have to do, so we're going to look at a few, and then you're going to practice this method on your own. So first example is 2x plus 3y equals 11 and negative 2x plus 5y equals 13. So with the elimination method, we're going to add or subtract. Here, we're going to look to add because I see a variable that has opposite coefficients. So this variable has 2, this variable has negative 2. So I know if I add them together, it will eliminate those variables. So we're going to add this equation, and we're adding everything. That's why I put it in a group. So I'm adding this, I'm adding the y's, and I'm adding the constants to the original equation. So when I add those, let's see what happens. So 2x and negative 2x eliminate to get me 0x, which is nothing, so I don't write anything for the x's. Then I add 3y and 5y, that gets me 8y. I still have the equal sign. And then I add the 11 and the 13, and I get 24. Okay, so 11 and 13 gets me 24. So now I have an equation that with step two, I can solve the equation using the, or solve the equation for the variable that was not eliminated. So we'll solve this equation by isolating y using division. We're going to divide both sides by 8, and we get y equals 3. Okay, so now that we've solved, we're going to take that y equals 3, and we're going to substitute it back into either of the equations so that we can find the value for the x. So it doesn't matter if you use the first equation or the second equation, it's still going to get you the same y. So we're going to take 2x, or sorry, it's going to get you the same x. So we'll take 2x plus 3y, but instead of y, we're going to write the number 3 equals 11, and then we solve for x. What I need to do first is simplify the multiplication. So I've got 2x plus 9 equals 11. Then I subtract both sides by the constant, so I get 2x equals 2. Then I divide both sides by 2, and I get x equals 1. So I now have an x coordinate and the y coordinate. I write them as my solution. So my solution is 1, 3. And then the last thing I need to do is check that solution in both original equations. So I'm going to take 2x, which is 1, so 2 times 1, plus 3y, which is 3, so 3 times 3 equals 11. I do my operations to check if I get a true statement. I get 11 equals 11. I take the other equation, negative 2x, so negative 2 times 1, plus 5y, so 5 times 3, equals 13. Again, I do those operations, negative 2 plus 15 equals 13, and then 13 equals 13. So because I get a true statement for both equations, this ordered pair is the solution to the system. All right, so let's go ahead and take a look at the second example. So the second example is x plus 5y equals 47 and x plus y equals 15. So we've got to determine if we need to reorder, do multiplication, or if we could just add or subtract. So I don't need to reorder because it has x first, y second, and then the constant in both of them. I don't need to do multiplication because I see a variable that has the same coefficient, and that's the goal when we're doing multiplication, is get a variable that has similar coefficients. So what I'm going to do is I'm going to subtract here because these coefficients aren't opposite right now. So to get rid of these x's, instead of adding them to cancel them, I'm going to subtract them to get rid of them. So we're going to subtract the whole equation. That means subtracting the x's, subtracting the y's, and subtracting the constants. So when we do x minus x, those eliminate, and we have no more x's. Then we do 5y minus y, which gets me 4y, because this has a coefficient of 1. And then we do 47 minus 15, and that gets me 32. Okay, so once I've done that, my second step is to solve that equation for the variable. My variable is y here. I'm going to solve by dividing by 4. I get y equals 8. Okay, after that, I take my answer and I substitute it back into one of the original equations. So I can take either one, it doesn't matter. I'm going to take x plus y, and y is 8. So I'm going to take that 8 and I'm going to substitute it in, equals 15. I chose this one just because there's no multiplication to do. I can just subtract the constant from both sides, and I get x equals 7. And then now that I have my x coordinate and my y coordinate, I can write them in an ordered pair and then check to make sure that that ordered pair is the solution to both equations. So let's do our check really quick. We're going to take the x plus 5y equals 47 and write 7 plus 5 times 8 equals 47. And then 7 plus 40 equals 47. Whoa, 74. And then 47 equals 47. So it works for the first equation. Let's check the second one. X, which is 7, plus y, which is 8, equals 15. And then 7 plus 8 is 15. 15 equals 15. Therefore, this is the solution to that equation. Okay, so let's take a look at the third example. With these examples, sometimes, like we said, we're going to have to do multiplication or reordering to make sure that the terms can be eliminated. So when looking at this, sometimes we're going to have to manipulate the equations to make it easy to eliminate. So the first thing that we're going to have to look at is all terms must appear in the same form in both equations, and usually that form is standard form. So ax plus by equals c. It doesn't have to be simplified standard form, but it needs to be x first, y second, and then equals c. So we may have to rearrange the terms either on the same side or by adding or subtracting to get all of the x and y on one side and the constant on the other. The other thing that you may also have to do is you may also have to multiply by So you may also need to multiply both sides by 1 or both of the equations by -1, okay, or another constant. That's really what you're going to do, because multiplying by -1 just means subtraction. That's all it is. So I really never multiply by -1, I just subtract the equation. But you may have to multiply by another constant besides 1, just to make it so that you can have variables that eliminate. And we'll talk about that in our next 2 examples. Okay, so let's look at example 3 on the back. So example 3 says 4x equals -3y plus 2. So, and then 5x plus 3y equals 2. So the problem that we have here is we have one equation that's in standard form and one equation that is not. So we need to get our first equation in standard form by taking the y and pulling it over here, which means we've got to rearrange the terms first. So the way we're going to do that is we're going to do the opposite of -3y by adding 3y to both sides. And so that equation is now 4x plus 3y equals 2. Okay? I know that I don't need to multiply because I see a variable that has the same coefficient. What I have to check for now is adding or subtracting. So I'm going to subtract because the coefficients are opposite. So I subtract that whole equation from the original. So I do my x's first. 5x minus 4x is 1x, or just x. Then I have 3y minus 3y, which cancel those y's, or they eliminate them, hence the elimination method. And then I do -2 minus 2, which equals -4. So after that, I look to solve for that equation. Solving, I really don't need to do any solving because 1 times x is just x, so x equals -4. After I do that, my next step is to substitute that -4 into either of the original equations. It doesn't matter which one you do, they're going to get you the same y. I'm just going to choose the first one. I'm going to substitute it into the original. I'm not going to substitute it into the rearranged equation. So the original equation was 4 times x, so I plug in my -4, equals -3y plus 2. So from here I'm solving for y. I do my multiplication first, I get -16 equals -3y plus 2. I subtract both sides by 2 and I get -18 equals -3y. And then I divide both sides by -3 and then I get y equals 6. So I now have an x and a y. I'm going to write them in an ordered pair, -4, 6, and then I'm going to check that ordered pair with both of the equations. So my original first equation was 4 times x, which is -4, equals -3 times y, which was 6, plus 2. I do my multiplication and get -16 equals -18 plus 2. I do my addition and get -16 equals -16, so that's a true statement. I also check with the second equation, 5 times -4 plus 3 times 6 equals -2. Multiplication first, -20 plus 18 equals -2. And then addition, -2 equals -2. So my ordered pair is the solution to that equation. All right, so last example, we're going to take a look at 4x plus 5y equals 35 and 2y equals 3x minus 9. So the first thing that we want to do is we want to rearrange so that the terms are aligned or so that they're alike. Again, the second equation is not in standard form, and again, it doesn't have to be simplified standard, but we do want the x on the other side. So we're going to subtract 3x from both sides. And now my equations are 4x plus 5y equals 35 and -3x plus 2y equals -9. Okay, after that, we need to figure out what we're going to multiply by. I've got to multiply one of these equations or both of these equations by a number so that I can eliminate them, because neither of the coefficients on my variables are the same number. I've got a 4 here and a -3 here, a 5 here and a 2 here. So we are going to check for what we can multiply by to get them to be the same. Okay, so in order to do this, we pick either of the variables to multiply. So you can either pick x's and you're going to find a common factor that you can multiply them by, or find factors that you can multiply them by that will get you a common product. So if I multiplied 4 by 3, I would get 12. If you multiplied -3 by 4, you would get -12. I like to choose the variables that already have opposite signs, so I don't have to worry about subtraction afterwards. If you chose 5 and 2, you would multiply this equation by 2 and this equation by 5, but they would both be 10, which means you'd have to go through and subtract instead of adding. I think adding is easier, but it's your preference. The way that we do this multiplication is we take our original equations and we multiply them, the whole equation, using distributing, by the number that will get us to that common product. So the common product we're looking for between 4 and 3 is 12. That's the least common multiple that they share. So we're going to multiply 4 by 3 and then all the other terms by 3, and -3 by 4 as well as all the other terms. So the way we do this is we distribute that 3 to all parts. So 3 times 4x gets me 12x, plus 3 times 5y gets me 15y, plus 3 times 35 gets me 105. Then we do the same thing with 4. 4 times -3x is -12x, plus 4 times 2y is 8y, plus equals 4 times -9 equals -36. Okay, so now that I've done that, I've created terms that are opposite coefficients of each other, and I can add those equations together. So we can add those coefficients, add those equations. The 12x and the -12x eliminate because they get 0. Then I add my y's, 15y and 8y is 23y. I bring down the equals, and then 105 plus -36 gets 69. After we do that, we solve this equation for y. So I'm solving by dividing both sides by 23. I get y equals 3. Then after I do that, I substitute y into one of the original equations, not the equations that we got after multiplying, but one of the originals. So let's substitute it in for, let's just do the 2y, which is 3. So 2 times 3 equals 3x minus 9. It's also the original before you reordered. I do my multiplication first. I get 6 equals 3x minus 9. I add 9 to both sides. I get 15 equals 3x. And then I divide by 3. I get x equals 5. So my ordered pair that I think is my solution is 5, 3. I check that ordered pair by plugging the numbers into the original equation. So 4 times 5 plus 5 times 3 equals 35. I do my multiplication, 20 plus 15 equals 35. And then I do my addition, 35 equals 35. So that equation works. My second equation is 2 times y was 3, equals 3 times x, which was 5, minus 9. We do my multiplication, 6 equals 15 minus 9, and then my subtraction, 6 is equal to 6. That is a true statement. Both of them are true statements, which means this ordered pair is the solution to the equation. All right, so you're going to do some practice on your own. If you have any questions, please feel free to ask. This method is typically used when we have both equations written in standard form, or they can easily be written in standard form, and none of the coefficients have a 1 or a -1 as their coefficient unless they can be easily eliminated.